Hi everyone, today we're going to study ordinary perpetuity. Let us first define perpetuity. A perpetuity is an annuity that has no end, or a stream of cash payments that continues forever. As there is no end to the term, it is not possible to find the future value of a perpetuity. However, the present value of a perpetuity can be found. Student scholarship payment is one of the popular examples of perpetuity. When the payments are made at the end of each period, we call it an ordinary perpetuity. Let us study now the present value of ordinary perpetuity. The present value of ordinary perpetuity is given by this formula. PV sub ordinary perpetuity equals a fraction where the numerator is PM all over another fraction that is R over N. This PV means present value of ordinary perpetuity. The PM means payment. The R means the periodic interest rate. And N is the period. Let us see this example. John provides a donation of $3,500 to a college with the provision that a scholarship is paid at the end of each year. If the money is invested at 12% compounded annually, how much is the annual scholarship? Let us first write the given of the problem, starting with the present value, that is PV, and it is that $3,500. Next is the rate, denoted by R, and it is this 12%. Let us convert this 12% into decimal. First, let us drop the percent sign and divide the 12 by 100. And the quotient will give us 0.12. Next is the number of period, and it says here compounded annually. It means our N equals 1. In this problem, we want to know the annual scholarship or the payment. Let us use our formula. Let us do the substitution now. The PV becomes 3,500 equals PM, that is what we want, all over the R over N. The R is 0.12 and the N is 1. We can simplify this denominator, which is also a fraction, and we can write 0.12. Let us cross multiply this denominator to the left side. So we have now the 3,500 multiplied by 0.12. And the product will give us 420. This is the payment or the annual scholarship per year. We will attach our dollar sign, and this is our final answer. Hi everyone, today we're going to study perpetuity due. A perpetuity is an annuity that has no end, or a stream of cash payments that continues forever. As there is no end to the term, it is not possible to find the future value of a perpetuity. However, the present value of a perpetuity can be found. When the payments are made at the beginning of each period, we call it perpetuity due. Let us now discuss the present value of perpetuity due. The present value of perpetuity due is given by the formula in here. PV sub perpetuity due equals PM plus a complex fraction here, where the numerator is PM and the denominator is another fraction that is R over N, where this PV means the present value of perpetuity due. PM means payment. R is the periodic interest rate, and the N is the period. Let us see this example. What is the present value of the perpetuity payments of $1,850 made at the beginning of each month if the interest is 12% compounded monthly? Let us write now the given of the problem, starting with the payment, that is PM equals this $1,850. Next is the rate denoted by R, and this is equal to 12%. Let us convert this percent into decimal. Let us drop first the percent sign and divide this 12 by 100. So this 12 over 100 equals 0.12. Next is the number of times compounded. That is the N, and it says here monthly. So we write here 12. We are looking now for the present value of the perpetuity. Let us write our formula here, and let us start the substitution. The present value equals PM, now change into 1,850 plus this complex fraction where the numerator is PM, and we change it now also to 1,850 all over this fraction R over N. The R is 0.12 and the N is 12. Let us simplify further. Let us begin with this denominator. 0.12 over 12 will give us 0.01. And then let us simplify this fraction, 1850 over 0.01, and we will get the value 185,000. This big number we will add to the payment of 1,850, and the sum is 186,850. This is the present value of the perpetuity. We will not forget to affix the dollar sign. And this is now our final answer. I hope you learned something from this video. See you again next time.